Welcome back to the channel FFBMD. Let's pray Goddess Saraswati to get knowledge from her. In today I will discuss law of motion. Question: what is Aristotle's fallacy or law of motion? Answer: an external force is required to keep a body in motion. Question: what is flaw in the Aristotle arguments? Answer: a moving toy car comes to rest because the external force of friction on the car by the floor opposes its motion. To counter this force, the child has to apply an external force on the car in the direction of motion. When the car is in uniform motion, there is no net external force acting on it. The force by the child cancels the force of friction by the floor. If there were no friction, the child would not be required to apply any force to keep the toy car in uniform motion. The law of inertia. If the net external force is zero, a body at rest continues to remain at rest, and a body in motion continues to move with an uniform velocity. This property of body is called inertia. Inertia means resistance to the change. Newton's first law of motion. Everybody continues to be in its state of rest or of uniform motion in a straight line unless compelled by some external forces to act otherwise. 2. If the net external force on a body is zero, its acceleration is zero. Acceleration can be non-zero only if there is a net external force on the body. 3. If there is no net external force on a body, it maintains its previous state of rest and uniform motion. Here in the above figure, a body rests on the table. Now, since reaction force equals to weight of the body, so book is at rest. Incorrect. This is the incorrect reasoning. What will be the correct reasoning? Since book is at rest, so reaction force must be equal and opposite to the weight of the body. Because R equals to W also implies that body move with constant velocity along R or W. Momentum. P vector. It is defined as the product of mass of the body and its velocity. That is, P vector equals to m into v vector. In component form, pxi cap plus pyj cap plus pzk cap equals to m into under bracket vxi cap plus vyj cap plus bzk cap. Here ijk cap are unit vector along x, y and z direction. So equating corresponding terms of ijk both sides, we have px equals to m into vx, py equals to m into vy, pz equals to m into vz. Now let's calculate unit of p. We have p equals to m into v. Now mass, unit of mass is kg and unit of velocity is meter per second. So unit of momentum will be kg meter per second. And dimensional formula of momentum will be mlt minus 1. Question: a body of mass 2 kg moving with velocity v vector 2I cap plus 3j cap plus 4k cap meter per second. Find its momentum along x, y and z direction. We have formula momentum vector p vector equals to m into v vector. So mass is given 2. So 2 into under bracket 2I cap plus 3j cap plus 4k cap kg meter per second. So 4I cap plus 6j cap plus 8k cap kg meter per second. Now from the above formula we get px is equal to 4 kg meter per second. That is momentum along x direction. Similarly, momentum along y direction py equal to 6 kg meter per second and pz momentum along z direction 8 kg meter per second. Now magnitude of momentum mode of p vector is given by under root px square plus py square plus pz square under root 4 square plus 6 square plus 8 square kilogram meter per second. Answer. Newton's second law of motion. The rate of change of momentum of a body is directly proportional to the applied force and takes place in the direction in which the force acts. Here consider a block is shown which is moving with velocity v. Now a force F start to act on the body v and its velocity changes to v plus delta v in time delta t. That it means that force F vector has acted on the body during the time interval delta t and its velocity has changed from v to v plus delta v. If under the action of force F vector the velocity of body changes from v vector to v vector plus delta v in time interval delta t, its initial momentum is mv vector and final momentum is m into v plus delta v. So change in momentum is given by delta p vector equals to p2 vector minus p1 vector, where p2 vector represent final vector and p1 vector represent initial momentum. So delta p equals to m into under bracket v plus delta v minus mv vector or equals to m into delta v vector. Now according to second law, applied force F vector proportional to delta p by delta t, or F vector equals to k into delta p by delta t, where k is a constant of force proportionality. Taking limit delta t tends to 0, we have F vector equals to limit delta t tends to 0 k into delta p by delta t equals to k into dp by dt. Question 1. For a body of fixed mass m, dp by dt equals to d by dt mv vector equals to m into dv by dt equals to m into a vector. Question 2. So from 2 and 1 F equals to k into ma vector. This is the another form of second law of motion. The SI unit of force 1 Newton is chosen such that the value k comes out to be 1. That is k equals to 1. Hence F vector equals to m into a vector equals to m into dp by dt, dp vector by dt. Definition of Newton. 1 Newton. It is that force which produces an acceleration of 1 kilogram meter per second square in a body of mass 1 kg. If F vector is equal to 0, this implies ma vector equals to 0. This implies a vector equal to constant, since mass cannot be 0. In component form, ax equals to 0, ay equals to 0, az equals to 0. The second law is obviously consistent with the first law. Question. Prove that first law is consistent with the first. Second law is the consistent with the first law. Solution. If F vector equals to 0, ma vector equals to 0, a vector equals to 0, dv by dt equals to 0, This implies v equals to constant or 0 equals to first law of motion. When velocity constant or 0, this represents first law of motion. Second law in component form, we have f vector equals dp vector by dt. This implies fx I cap plus fy j cap plus fz k cap equals to dpx by dt into I cap plus dpy by dt into j cap plus dpz by dt into k cap. So we have fx equal to dpx by dt equals to ma into ax, fy dpy by dt equals to may, fz dpz by dt equals to maz. This means that if a force is not parallel to the velocity of the body, but it makes some angle with it, it changes only the component of velocity along the direction of force. The component of velocity normal to the force remains unchanged. Example: in the case of projectile motion, because no force is acting along the x direction, so when x direction velocity at the point of projection, it is v naught cos theta naught, and after time when its velocity becomes v vector, then its velocity is v cos theta, but there is no force along the horizontal direction, so velocity should not change. So this velocity must be equal to this velocity. So we have v cos theta equals to v naught cos theta naught. Example: a bullet of mass 0.04 kg moving with a speed of 90 meter per second enters a heavy wooden block and is stopped after a distance of 60 centimeter. What is the average resistive force exerted by the block on the bullet? Let's first discuss the situation. Here a block is shown. Now a bullet hits these blocks at this point with velocity v naught, means initial velocity of bullet is v naught. Now when it enters the block, a resistive force from the block acts on the bullet in opposite direction, so its velocity gradually decreases and a time reaches when its velocity becomes 0, that is finally its velocity becomes 0, and during this time it travels a distance x from the end of the block. Now we have discussed the situation of the bullet and block. So from above discussion we can calculate what we are asked. Let we have v square is equal to v naught square plus 2as. We have this formula from linear motion. Here initial final velocity of bullet here is equals to 0, so v equals to 0. Initial velocity, let v naught is equals to v naught, and s, distance traveled by the velocity in the block, is x, the s equals to x. So we have 0 square v naught square plus 2ax, hence a equals to minus v naught square by 2x. Here negative sign shows that the acceleration is acting opposite to the motion of the bullet. So putting value we get minus 6750 meter per second square. Now we have f equals to ma. Putting value of mass 0.04 and putting the value of a, we get minus 2700 Newton, 270 Newton answer. Here also negative sign shows that force is resistive, that is acting opposite to the motion of the bullet. The motion of a particle of mass m is described by y equals to yt plus half gt square. Find the force acting on the particle. Solution: we have y equals to yt plus ut plus half gt square. Now we know that Vy equals, that is velocity along y direction, equals to Vy equals to dy by dt, or putting value of y, we get u plus half g into 2t, or u plus gt. This imply ay. Now we can calculate ay, that is acceleration along y direction, dvy by dt equals to 0 plus g equals to g. Hence force along y direction Fy equals to m into ay equals to mg. Answer. Impulsive force. A large force acting for a short time to produce a finite change in momentum is called an impulsive force. That is, when a force, a very big force, acts for a very little time, then it produces a finite change in the momentum of the body, and that force is called impulsive force. Now impulse, I. The change produced in the momentum of a body due to impulsive force is called impulse. So impulse equals to change in momentum equals to impulsive force into time interval. So I vector equals to delta P vector equals to F vector into delta T. Question. A batsman hit back a ball straight in the direction of the bowler without changing its initial speed of 12 meters per second. If the mass of the ball is 0.15 kg, determine the impulse imparted to the ball. We have change in moment delta P, impulse equals to change in momentum delta P equals to P2 minus P1. That is final momentum minus initial momentum. Here situation is shown. The here ball is coming to the, this represent bat. So this, when it strikes the bat and return back with the same speed. Now this velocity is the initial velocity and this velocity is the final velocity, or you may ask, this momentum is initial momentum and this momentum is final momentum. So representing it in the vector form, we have mv into minus I cap minus mu into I cap, equals to minus, because v is equals to the initial velocity, so v can be used as u. So minus mu into I cap minus mu into I cap equals to minus 2 mu I cap. Hence the magnitude of momentum mode of delta P equals to 2 mu. Putting the value, we get 3.6 Newton. Hence impulse imparted to the ball is 3.6 Newton. Answer. Now Newton's third law of motion. To every action there is always an equal and opposite reaction. This is called third law of motion. Forces always occurs in pairs. Force on a body A by B is equal and opposite to the force on the body B by A. Consider the situation shown in here. A spring is shown. We placed a block on the spring. Now block, due to gravity, block exerts a force on the spring, and similarly the spring exerts the force upward direction on the block. The situation is shown here. The normal force by the spring on the block is in upward direction, and gravity acts on this body in downward direction, which is equal to mg. So because it is in equilibrium, so n equals to mg. Similarly in this case, earth acts on the body m with a force f. With same force, this body acts on the earth that is F equal to G mm by d square and F equals to G mm by ds. Both forces are same and in opposite direction. There is no cause-effect relation implied in the third law. The force on A by B and the force on B by A acts at the same instant by the same reasoning. Any one of them may be called acting and other reaction. Any one of them may be called action and other reaction. Action and reaction forces acts on different bodies, not on the same body. Consider a pair of bodies A and B. According to the third law, FAB equals to minus FBA. That is, force on A by B equals to minus of force on B by A. Thus, if we are considering the motion of any one body A or B, only one of the two forces is relevant. It is an error to add up the two forces and claim that the net force is zero. However, if we are considering the system of the two bodies as a whole, then FAB and FBA are internal forces of the system A plus B, and they add up to give a null force.